Hi there, and welcome to this Excel tutorial. In this video, I'm going to be showing you a couple of statistical equations with which you can analyze the data you collect. I'm also going to show you how to insert and format error bars on the graphs that you make. First of all, you can see that I have 4 sets of fictitious data that are already typed into Excel. Each data set is comprised of 15 data points. What these data represent, quite frankly, don't matter for the purpose of this tutorial, beyond the fact that they represent 4 different sets of values that we wish to compare to one another. That explains why the graph shown is a bar graph. At the bottom of each of the sets of data, we have 4 statistical values: average or mean, standard deviation, standard error of the mean, and plus or minus 2 standard errors of the mean. A previous video already demonstrated how mean is calculated, but I will highlight one of the cells, like B17, to remind you of the formula used. It is equals average B2 through B15. The formulas for average in the remaining 3 columns are set up in the exact same way. Standard deviation is a measure of how much variation there is in a set of values. A lower standard deviation would represent a data set whose values are clustered closely together. On the other hand, a high standard deviation would mean that the values in the data set are more spread out. The standard deviation equation is set up very similarly to the one for mean. Let's look at cell B18 to see that Excel function. It is equals STDEV for standard deviation, and then, just like with average, in the parentheses is the range of cells I want to be used in the calculation, B2 through B16. For the remaining data sets, it's set up in the exact same way. In science, when we collect data or take measurements, the values that we get are actually just a sample of a much larger set of values that would be impossible to take measurements on. For example, let's say you wanted to determine the average maximum speed of a cheetah. Because it would be impossible to measure the speed of every cheetah in existence, we would clock the speeds of random samples of cheetahs, maybe 40 or 50 of them. The average speed of those 40 or 50 cheetahs would then be used to represent all cheetahs on Earth. But how close is the sample average from those 40 or 50 to the actual true average of all cheetahs? That's what standard error of the mean is used for. A lower standard error of the mean tells us that our sample average and the actual average are relatively close together, whereas a much larger standard error of the mean indicates that the sample average and the true average are relatively farther apart. Here is the equation for standard error of the mean, so let's look at cell B19 to see what the Excel function is for calculating standard error of the mean. It is equals STDEV, for standard deviation again, then the range of values in parentheses, / SQRT, open parentheses count, open parentheses again, followed by the range of values, then 2 closed parentheses. The final value that we need is plus or minus 2 standard errors of the mean. While we aren't going to go into the statistical explanations behind this, This variable represents a 95% confidence interval. What this expresses is that we are 95% certain that the true mean falls within that particular range. Once we add in the standard error bars to the graph here, they should become a bit more clear. In order to calculate plus or minus 2 standard errors of the mean is quite easy if we look at cell B20. It is simply the standard error of the mean from the cell right above it times 2. Each of the remaining columns is set up in the exact same way. Now, let's incorporate error bars into our graph. As you can see, I have a very generic graph already created and color-coded to align with each of the 4 datasets. The values represented by each of the bars is the mean for each of the datasets. Of course, were this a graph representing real data, the title, axis labels, and axis units would be far more descriptive. Now that that disclaimer is out of the way, let's add in the standard error bars. Depending on your version of Excel, there are a couple of places to look to include the standard error bars. First, click anywhere on the graph. You may see the green Chart Elements button pop up in the upper right. If not, choose the Design tab from the menu and then click on Add Chart Element. Choosing that route, you would select More Error Bars options. If using the green Chart Elements button, select the options from the arrow to the right of error bars. Then you're going to choose More Options. Now you should see the Format Error Bars options menu. Scroll down to the bottom of the menu and select Custom, then Specify Value. We're doing this because Excel defaults to a fixed value for the error bars, but we want to tell Excel to use plus or minus 2 standard errors of the mean for our error bars. Clicking a specified value, a small box opens, allowing you to select what you want to represent the positive error value, plus 2 standard errors, and the negative error for minus 2 errors. Clicking here will allow you to highlight the cells that you want to choose as your positive error value. I will select the plus or minus 2 standard error for each of those data sets. Click here to confirm your choice. Now simply repeat the process for the negative error value. Once your positive and negative error values are selected, click OK. Now let's close the Format Error Bars menu so we can see the completed graph. Each of the 4 bars now has a standard error bar that represents plus or minus 2 standard errors of the mean. But what does this mean in simple terms? The heights of each of the bars represents our sample means for each of the data sets. The error bars represent the location of the actual true mean with 95% certainty. Additionally, when error bars overlap, as they do in the blue and purple data sets, it suggests, but doesn't confirm, that the differences in the values in those 2 data sets are not statistically significant. Thanks for watching. Enjoy your graph making.